Do you know what is the sum of the exterior angles of any triangle?
No, ma'am.
Okay, let's look at the simulation here. If you drive along the triangle, every turn when you what does it make?
Ma'am, a full circle.
Absolutely right, and that is?
Ma'am, a 360-degree angle.
Great work, Vansh.
Math learning should not feel like detention. Swap endless worksheets with engaging one-to-one classes by math experts.
Hi, Ankit. How are you? Do you know what is the sum of the exterior angles of any triangle?
No, ma'am.
Okay, let's look at the simulation here. If you drive along the triangle, every turn makes an exterior angle. When you take 3 turns, you are at the initial position. So, what does it make?
Ma'am, a full circle.
Absolutely right, and that is?
Ma'am, a 360-degree angle.
Great work, Vansh.
Math learning should not feel like detention. Swap endless worksheets with engaging one-to-one classes by math experts.
Hi, Ankit. How are you? Do you know what is the sum of the exterior angles of any triangle?
No, ma'am.
Okay, let's look at the simulation here. If you drive along the triangle, every turn makes an exterior angle. When you take 3 turns, you are at the initial position. So, what does it make?
Ma'am, a full circle.
Absolutely right, and that is?
Ma'am, a 360-degree angle.
Great work, Vansh.
Math learning should not feel like detention. Swap endless worksheets with engaging one-to-one classes by math experts.
Hi, Ankit. How are you? Do you know what is the sum of the exterior angles of any triangle?
No, ma'am.
Okay, let's look at the simulation here. If you drive along the triangle, every turn makes an exterior angle. When you take 3 turns, you are at the initial position. So, what does it make?
Ma'am, a full circle.
Absolutely right, and that is?
Ma'am, a 360-degree angle.
Great work, Vansh.
Math learning should not feel like detention. Swap endless worksheets with engaging one-to-one classes by math experts.
Hi, Ankit. How are you?
Hi everyone and welcome to this workshop masterclass on logical thinking. My name is Manan and I am going to be your instructor for today. We are going to do some very cool stuff on logical thinking. We are going to talk about odd and even numbers and a lot of very fun problems on this theme. So I hope everybody is excited. I want all of you to first tell me in the chat where you are joining from. So I can see all your comments in a screen on to my right. So I just want you to tell me where you are joining from and are you a QMath student or not. So if you are a QMath student, just write yes. If you're not a QMath student, let me know that as well. So where are you joining from and whether you are a QMath student or not. Let's take a few seconds. Hope to see everybody's responses in the chat. and we'll also give some other students who would be joining in by now some time to do that. So tell me where you're from and whether you are a QMath student or not, and perhaps you are a teacher or a parent, so let me know that as well. So I can see students from Canada, US, San Antonio, Texas, all right. Most of you seem to be joining from the US, so welcome to all of you. Whether you're joining from the US or elsewhere, I hope everybody is looking forward to what we are going to do today. And once again, welcome to today's session. So let's get started. What do you think we are going to learn today? So odds and evens, have you studied this topic in your school? Have you done it as part of your math curriculum? Odd numbers, even numbers. Are you familiar with this topic or not? So just let me know in the comments what you think we are going to work on today. And also, I want you to tell me, if you had a choice to pick a math superpower, what would that be? So here are 4 options that you see on the screen for a math superpower. So you could solve any problem, or you never make a mistake, or you're super fast at calculations, or perhaps you always think logically. So which of these 4 math superpowers would you choose if you had the choice? So this is a YouTube poll. You should be able to see options in the chat window. So just pick the math superpower you would want for yourself. Most of you are saying A and D, okay. So can solve any problem or always thinking logically. I'm actually a bit pleasantly surprised actually, because I've heard many students talk about how they would want to be super fast at calculations, or they would never want to make a mistake. But actually making mistakes is a natural part of learning math, and math is also much more than just being fast at calculations. Math is about logical thinking, deep problem solving. So I'm glad to see many of you actually talking about having these math superpowers, solving any problem or thinking logically. So, but anyway, whatever you chose, this was just a fun question to get all of you into the groove. So I think we are now ready to get started. I hope everybody is excited, and so let's dive right into the first set of puzzles that we will work out on odd and even numbers and the idea of odd and even. So this is level 1 puzzles. So these are easy puzzles, easy problems. Some of you might find them easy, but don't worry. We also have level 2 problems, and then we'll do level 3 problems or puzzles, and then ultimately we will end this session with a very fun Kahoot quiz. So be attentive, listen to me carefully. If you want to take notes, have your notebook and pen out, and make sure you are noting down all the key ideas, because at the end of the session we'll have a fun Kahoot quiz, and that will test you on everything that I'm going to teach you now through these puzzles. So let's get started. We'll first do some very simple odd and even logic puzzles. So here is our first problem. There is a river in a town, and there are 2 sides of the river. So there's this side which is A, and then on this side, this is the side we're calling B. Let's say that you are standing on side A. After you cross the river 5 times, which side will you be on? So that's the question. So after you cross the river 5 times, which side will you be on? Will you be on side A, or will you be on side B? Let me know quickly in the comments, which side will you be on? So a lot of you saying B, but I think Pratibha is saying it depends. Not really actually. It's actually, most of you are saying B, so that's correct. So after you cross it once, you are on side B, then you cross it again, you are on side A, then you go to side B, side A, and side B. So that's the pattern here. So what's happening is you start from A, once you cross it once, you get to B, then you cross it again, you get to A, you cross it again, you get to B, and so on. So after one crossing, you are at B. After 2 crossings, you're back to A again. After 3 crossings, you go to B. After 4 crossings, you're back to A again. So the question here is, or what I want you to think about is, what is the rule here? So if I tell you, for example, that after 200 crossings, where will you be? What will be your answer? What is the rule here? What is the pattern here that tells us which side you will be on when you cross the river a certain number of times? So let me know in the comments what you think. What is the pattern here that tells us which side will be on after crossing the river a certain number of times? Satish Mohandas says 200 is B. Are you sure? Mansi says odd is B, even is A. Okay. So after 1 crossing, you are at B. After 2 crossings, you're back to A. After 3 crossings, you're at B. After 4 crossings, you're back to A. So the pattern here really is, if the number of crossings is an odd number. So what are odd numbers? Odd numbers are numbers like 1, 3, 5, and so on, which are not multiples of 2. So if the number of crossings is an odd number, then you will be at B. So at the first crossing, then at the third crossing, and so on. So you'll be on side B. But if the number of crossings is even, then you will be on side A, your original side. And it's very easy to see why. An odd crossing means you would have crossed over to this side. So let's say first crossing, you go to side B. Then second crossing, you come back to side A. Then third crossing, you go to side B. Then fourth crossing, you come back to A. So you're alternating between sides B and A depending on what the number is. So at odd crossings, 1, 3, and so on, you are on side B. At even crossings, you are on side A. So if I ask you now, where will you be after 1000 crossings? So you just need to think about what 1000 is. Is it an even number or is it an odd number? Since 1000 is an even number, you can now directly say that you will be on side A after 1000 crossings. So that's really the idea here. That's the rule here. Very simple, very straightforward. And yeah, so now some questions based on that. Where will you be after 30 crossings? So I'll do the first 2 for you, and then I'll maybe ask you this one. So after 30 crossings, where will you be? So 30 is even, so you will be on side A. Where will you be after 75 crossings? So 75 is odd, so you will be on side B. But now what about this? This is a very large number. Some of you may not even have seen this number or such a large number. This is 1,000,001. So 1,000,001 crossings. Where will you be? Will you be on side A or will you be on side B? What do you think? Okay. All of you are doing really well. Most of your answers coming in are correct. So yes, 1,000,001 is an odd number because you have a 1 at the end, and therefore after an odd number of crossings you should be at side B. So after 1,000,001 crossings you will be on side B. Okay, so that's the logic here. As I said, fairly straightforward, but we will steadily build on this step by step and get to more challenging puzzles. Okay, now here's a question for you. So this is a YouTube poll, so you should be able to see options in the chat window. So the question is very straightforward. You are on side A and every day you cross the river 3 times. Which side will you be on after 1 week or 7 days? So will you be on side A or will you be on side B? So you should see 2 options, A and B, in the chat. Which side will you be on after 1 week if you are crossing the river 3 times every day? Wow, okay. 81% of you have picked, actually close to 90% now have picked side B. So that's amazing, and that's correct because you're crossing the river 3 times every day, and for over 7 days that's a total of 21 crossings. So 21 crossings, 21 is an odd number, and therefore you will be on side B. So the correct answer is side B, and most of you seem to have gotten this correct. Okay. Now we will go to this idea. We'll now talk about this idea of parity. So we have spoken about odd and even numbers, and the idea here is what is called parity. So remember this word parity. parity is simply the property of a number of whether that number is even or odd. So, the way we use this word is we say numbers like 2, 6, 14, 76, etc., which are all even numbers, they are numbers of even parity. So, they are even numbers or they are numbers of even parity. So, that is how we use this word, and these are all numbers that are divisible by 2. But then you have odd numbers, numbers that are not divisible by 2 like 3, 17, 19, 87 and so on. So, you can think of your own odd numbers. So, all of these numbers are what we call numbers of odd parity. So, odd parity, which is numbers that are not divisible by 2. So, parity is simply the property of whether a given number is even or odd. And there is this very powerful and very interesting visual model to think about parity and to really understand this concept at a deeper level. So, if you think of any even number, like let us take 6, and you try to draw a visual model for 6, you can draw it in this balanced manner where you have 3 circles in one row and 3 circles in another row adding up to 6. So, if you look at the visual model for 6, it is a balanced model in the sense that these circles come in pairs. So, you have 2 circles here, you have 2 here and you have 2 here. But if you think about the visual model for an odd number, like you take 5, you have 2 circles here, you have 2 circles here, but then this 5th one is unbalanced, so there is no other circle to pair up with this. So, this model here is what we will call an unbalanced model. So, for any odd number, the visual model will be unbalanced. For any even number, the visual model will be balanced. Now, this is very powerful because it helps you to think about what happens, for example, when you combine even numbers or when you combine odd numbers and so on, and we will come to those ideas in a bit. But now, here is problem 2, which kind of builds on the idea we just spoke about. Which box will you pick the numbers from? So, you have 2 boxes, the red box has all odd numbers and the green box has all even numbers in it, and you have to make 25. So, let us say you have to add a few numbers or you have to add 3 numbers to make 25. Which box will you pick these 3 numbers from? So, and you have 2 options here. You can pick the 3 numbers only from the odd box or 3 numbers only from the even box. Which of the 2 boxes will you pick your 3 numbers from to make 25? Let us see how many of you get this right. Okay, many responses coming in, all of you saying odd box, so that is great. Yeah, the answer is indeed pick numbers from box, the odd box, because if you pick numbers from the even box and you pick 3 numbers from the even box, they will add up to an even number, and this is where our visual model for parity comes in. So, I want you to imagine now, let us say combining 2 even numbers. So, let us say we think of adding 4 and 6. So, the visual model for 4 will be a balanced model like this. So, 2 circles in each row. The visual model for 6 will also be a balanced model. So, 3 circles in each row, and now if you put these 2 models together, you will once again get a balanced model. So, you will get 5 rows in 5 circles in one row, 5 circles in the next row. So, you will get a total of 10, which is again even. But the idea here is very simple. You combine 2 even numbers, you get an even number, which means that if you pick 3 numbers from the even box and you add them up, you will get an even number. But what if you pick 3 numbers from the odd box? So, now let us think about combining 2 odd numbers. So, let us take 3 and 5. So, the visual model for 3 will be unbalanced like this. So, you have 2 in one and 1 in the other row like this, and then the visual model for 5, we could draw it like this perhaps. So, 4 like this and then 1 over here like this. So, this is the visual model for 3, here is the visual model for 5, and now I want you to imagine it like this, somewhat like this. So, you have this unbalanced thing here and you have this unbalanced model like this, but now you bring them together, you fit them, and this circle will now pair up with this circle to create a balance, and you will get an even number. So 3 plus 5 is 8. So if you combine two odd numbers together, you will get an even number. And now what happens if you combine an odd and an even number, right? So that's the third case. So if you take, let's say, an odd number, an even and an odd number. So let's take 4, which has this visual model, and 3, which has, let's say, this visual model. And if you now combine 4 and 3, you will get an unbalanced model because this circle will not get balanced. So combining an odd and an even number gives you an odd number. So those are your 3 possible cases, and now you can see how thinking in terms of the visual model of parity makes thinking about these things very easy. 2 even numbers add up to an even number, 2 odd numbers add up to an even number, but an odd and an even number add up to an odd number. Now what does that mean for this problem? You have to make 25, and if you now pick 3 odd numbers from the odd box, from this box, 2 of them will add up to an even number, and then you add a third odd number, you will get an odd number. So to make 25, you will need to pick 3 numbers from the odd box, because that's the only way you can make an odd number, by adding up 3 numbers. So let's see an example. So for example, if you pick perhaps let's say 1, and now you need 24 more. So let's pick 11, and that's 12, and now you need 13 more. So let's pick 13. So 1, 11 and 13 will add up to 25. So this is one combination that works, but you can think of several other combinations of 3 odd numbers that will add up to 25. So the summary for this problem is that you would pick the 3 numbers from the odd box and not the even box, and most of you actually got this one right. Okay. Now this next one here is you have to pick numbers from both boxes. So can you do that? Can you make 25 if you are forced to pick numbers from both boxes? How could you do that if you had to do that? You have to pick numbers from both boxes. How can you make 25 by using numbers from both boxes? So can someone come up with an idea? How can you make 25 by using numbers from both boxes? So okay, Mansi Gupta says 2 from even, 1 from odd. Interesting. Okay, let's wait for a few more ideas. Vidya Chidambaram says 12, 12, 1. Satish says 10, 10, 5. SS says 2, 18, 5. Okay, so I think some of you have gotten the idea here. So you have to use numbers from both boxes. So which means that you could take 1 even and 2 odd, or you could take 2 even and 1 odd. So these are the 2 possibilities here. You're not allowed all 3 as even, you're not allowed all 3 as odd. You can do one of these 2 things. But if you pick this first combination, which is 1 even number from the even box, 2 odd numbers from the odd box, what will be the parity of the sum? So that is what I want you to think about. What will be the parity of the sum if you take 1 even and 2 odd numbers? Well, these 2 odd numbers will add up to an even number, and that even number will combine with this even number to give us an even number. So in this combination, we can't really make 25. But if you have 2 even and 1 odd, what does this give us as the parity of the sum? So 2 even numbers will add up to an even number, and that combined with an odd number will add up to an odd number. And therefore, this is the combination that makes it possible to make 25. And some of you have actually given correct examples. So if we pick, let's say, 1 from the odd box, and we could pick perhaps 10 and 14 from the even box. So we have 14 plus 10, that's 24, and then 1, that's 25. And once again, there are several different combinations here. But the key idea here is that you would need 2 numbers from the even box and 1 number from the odd box to make this happen. Okay. So here are some more questions for you, practice challenge for you, and try answering these quickly. So can you make 40 using 3 numbers? And here are some constraints: from only box E, from only box O, odd box, 2 from odd box, 1 from even box, 1 from odd box, 2 from even box. So your answer should be in the form yes, no for each part. So for example, your answer could be yes, yes, no, no. So just tell me these 4 answers together in the chat. What are your 4 answers to this problem? So you can use Y or N, or you can use yes, no, but I need all 4 answers together. Lippy Singh says yes, 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 no. So we'll see. We'll give it a few more seconds for others to catch up. Shravan says yes, no, no, yes. Deepika says yes, 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 no. Kamaldeep says yes to all. Satish says yes, 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 no. Okay, I'm going to do this now, and we'll discuss all the 4 parts. So if you pick 3 numbers only from the even box and add them together, you will get an even number, and therefore making 40 should be possible by using 3 numbers from the even box. In fact, if you take, let's say, 8, 12 and 20, that actually gives you 40 from 3 even numbers. So for the first part, the answer is yes. From only the odd box, so if you take 3 numbers from the odd box, their sum will be odd. We've just seen that. So if you add 3 odd numbers, so I'm using O for odd here, so O, O, O. 2 of the odd numbers will give you an even number, and then you add the 3rd odd number, you get an odd number. So how can you make 40 using 3 numbers only from the odd box? That I'm not sure why so many of you said yes to this second one. So this doesn't seem to be possible, so the answer to this should be no. If you take 3 numbers only from the odd box, making 40 should not be possible. Now what about 2 numbers from the odd box and 1 from the even box? So 2 from the odd box will add up to an even number, and that combined with the even number should be an even number. So this should be possible. In fact, if you take, let's say, 10 from the even box, and then you need to make 30 more. So let's take 13 and 17 from the odd box. So that gives you 40. So this is possible. So yes to the 3rd one. What about 1 from the odd and 2 from the even? So 2 numbers from the even box will give you will sum to an even number, and add that to this odd number, you get an odd number. So for making 40 in this combination is not possible. So no to the 4th one. So the actual correct answer is yes, no, yes, no. So yes, no, yes, no, and I think several of you have gotten this combination correct now. So this is how you have to think about this. You have to think about the parity of the combination. If you combine the numbers given the conditions, you have to think about whether the resulting sum will be even or odd, and then you have to see what you are trying to make. In this case, you are trying to make 40, which is an even number, and in the 2nd and the 4th conditions, getting to an even number is not possible. Okay, so that's the logic here. I hope you liked this one. Now let's keep moving forward. This is a poll for you now, and you should see the options in the chat channel. You have to make, we are talking about making 35. So if you have to make 35 using 5 numbers, which of these will not work, won't work? If all 5 numbers are odd, there's 1 odd or 4 evens, 2 odds or 3 evens, and 3 odds and 2 evens. Which of these will not work to make 35? That's the question. Which of these options will not work to make 35? So you have to think once again in terms of the parity of the combination. So for each of these options, think very carefully about what will be the parity of the sum. Will it be odd? Will it be even? And remember that 35 is an odd number. You have to get to odd parity. So in which of these options is getting to an odd parity not possible? Think carefully. think carefully. I'm going to give this a few seconds because this is kind of the crux here. This is the key idea here. And if you are able to get this right, it means you have truly understood what we are trying to do here. Okay, I am going to do this now. I can see 40% of you are saying C, so that's the top choice so far. But then about 25% of you are also saying A. So let's see. So A, the option A is 5 odds. So if you have 5 odd numbers, what will be the parity of the sum? So think of 5 odd numbers. So I'm using these. This is O. So 4 odds and then 5. So total 5 odds. 5 odd numbers. So 2 of these odds will add up to an even number, these 2 will add up to an even number, and then this is odd. So now if you combine them, you get even and even, that's even, and then that even combined with this odd is odd. So if you add 5 odd numbers together, you will get an odd number, and 35 is odd. So this should be possible. So finding 5 odd numbers that add up to 35 should be possible. So this is not really our answer here. What about 1 odd and 4 evens? What is the parity of the sum if we combine 1 odd and 4 evens? So 4 even numbers will add up to an even number. Combine that with 1 odd number, you get an odd number. So once again, you can get to 35 in this combination. What about 2 odds and 3 evens? So 3 even numbers will add up to an even number. 2 odd numbers will also add up to an even number. And then you combine the 2 resulting evens, you will get an even number. So here the parity is of the combination is even and not odd, and therefore getting to 35 should not be possible here. And here in option D, 3 odd numbers will add up to an odd number, 2 even numbers will add up to an even number, and then odd plus even will be odd. So getting to 35 should be possible. So the correct option here, the one that will not work to get to 35, is option C. So that is the correct answer here. And I think 45% of you got this right, and if you got this right, then that means you've understood truly what we're doing here. If you did not get this right, don't worry. I hope you followed my explanation and you now understand what's going on here. Okay, so let's keep moving now to problem 3. And remember, right now we are on level 1, so these are the simple puzzles of this masterclass. We're actually going to do more challenging puzzles soon. So this is problem 3 now. And here's what it says. So you have this 5 cross 5 grid. Can you cover this 5 cross 5 square grid with these 2 cross 1 dominoes? Can you cover this 5 cross 5 square grid with 2 cross 1 dominoes? Yes or no? Yes or no, can we cover this 5 cross 5 grid with 2 cross 1? Okay, most of you are saying no, and that is indeed correct. Why is that? Because the 5 cross 5 grid has 25 squares or 25 cells, but this 2 cross 1 grid has only has 2 squares. So if you start fitting this grid with these dominoes, you will ultimately be left with 1 empty square. And why is that? Because 25 is odd, it's not even, it's odd, but the number of dominoes in the number of squares in the 2 cross 1 domino is 2. So if you start placing these dominoes on the grid, you will ultimately get to covering 24 of the 25 squares, but 1 of the squares will be left, and therefore you cannot cover the square grid with 2 cross 1 dominoes. So this is a very different context in which parity comes up, odd and even, the theme of odd and even comes up. The square grid has an odd number of squares, but the domino has an even number of squares, and therefore this covering is not possible. But this was simple. Let's maybe get to more complex examples soon. So here are 3 grids that you see. There is a 4 cross 4 grid, there is a 6 cross 5 grid, there is a 3 cross 5 grid. which of these grids can be covered with 2 cross 1 dominoes? So, tell me in the chat which of these grids can be covered with the 2 cross 1 dominoes. Lippy Singh says 4 cross 4 and 6 cross 5. And so do several more of you, 1 and 2. So, that is correct. So, the 4 cross 4 grid has 16 squares, and therefore, covering this with 2 cross 1 should be possible. And if you actually visualize this in your mind, it is actually fairly straightforward to do this. You place a domino here, then one here, one here, one here, one here, one here, one here, and then one here. So, you can actually quickly visualize how the 4 cross 4 grid can be covered with this. Same for 6 cross 5. So, there are 30 squares, and you can see that this edge is even. So, there are 6 squares along this edge. So, if you think about placing the dominoes like this, so one here, and then one here. So, that covers one row, and then you can do the same in every row. So, you can actually cover the whole grid with 2 cross 1 dominoes quite easily. But doing that is not possible here because the number of squares itself is odd in this case. So, 3 cross 5, so you have 15 squares. So, if you try covering this with dominoes, it will not work out, and you can actually visualize this. So, if I let us say try doing that, so I can draw a domino here, one here, so that is 2, then 3, 4, and then 5, and then I have this column left. So, I can put a domino like this, so that is 6, and then 7. So, I have covered 14 squares in total, but you can see that this square is left, and the reason is simply that 15 has odd parity, and therefore, one square will always be left no matter how you place the dominoes. Okay, so that was straightforward as well, but now here is a question for you based on a similar idea. So, you see 4 grids here, 6 cross 6, 5 cross 4, 7 cross 3, and 8 cross 7. Which of these grids cannot be covered by this 2 cross 1 dominoes? So, there is one option here that cannot be covered with 2 cross 1 dominoes. Which one is it? Wow, very fast. 92% of you are already saying C. Okay, so the answer is indeed C, because all the other grids have an even number of squares, and at least one edge is even. So, in this case, for example, it is 6 cross 6, so 36 squares on this grid, and both edges have an even number of squares. So, covering should be easy. So, like 1, 2, 3, and then you do the same thing in every row. 5 cross 4, again covering this should be possible. So, 20 squares in this grid. If you place a domino like this and another one like this, and then do this in every column, that will work. Same for 8 cross 7, so 56 squares, and then one of the edges has an even number of squares. So, you can place a domino like this. So, 1, 2, 3, 4, and then do this in every row. But in option C, you have 7 cross 3 or 21 squares, and the 2 cross 1 domino has only 2 squares, So, this is even, but this is odd parity. So, you will not be able to cover this completely with 2 cross 1 dominoes. One square will always be left. In fact, let us quickly see, let us quickly try doing this covering. So, I will place 1 here, so 2 here, 3 here, I will place maybe a 4th one like this, then 5, 6, 7, then 8, 9, 10. Okay, so I have covered 20 squares, but now this one is left. So, no matter how you try placing your dominoes, one square will always be left. Okay, most of you got this one right. Now, we will come to level 2 puzzle. So, we will now increase the level, we will stay on the same theme of parity of odds and evens, but now we will apply the logic in some more challenging situations. So, here is problem number 4. So, you have these 11 gears that are arranged like this. So, this is a very cool problem, by the way. So, I want you to think very carefully about this one. So, there are these 11 gears that are arranged in this circular manner, and let us say you try rotating one of the gears. So, let's say you rotate this gear 1 and you kind of apply a rotational force on it so that it rotates like this. Will this whole arrangement of gears rotate or will it get stuck? What do you think? Will it rotate or will it get stuck? If you are saying it will get stuck, Lippy Singh for example is saying I think it will get stuck. Ayush says no rotation because the number of gears is odd. A lot of you are saying stuck, but if you are saying stuck, I want you to tell me why. Why will it get stuck? Why will why will it get stuck? I need a reason. I need the reasoning here for why this will get stuck. Some of you are saying odd, okay, yes, the number of gears is 11, so it's odd, but then what? So what? If it's odd, so what? Why should the arrangement get stuck if the number of gears is odd? Okay, so Satish says stuck because the rotation cycle is going in different directions. Udesha says something similar, one gear and the other gear will rotate other ways. Sudhir says 11th gear turns the first gear in the opposite direction. Okay, we'll come back to this in a bit. Let's understand the underlying ideas here. So how do gears rotate? Let's think about this carefully. Okay, so imagine two gears that are interlocked with each other and they are both rotating. So the key idea here is very simple. If one gear is rotating in a certain direction, the other gear must rotate in the opposite direction. So in this case, for example, this gear, this first gear here is rotating in this direction, which is clockwise. So I'm using C to represent clockwise. Then this other gear must rotate in the opposite direction, which is anti-clockwise. So if one gear rotates clockwise, the other gear, the adjacent gear must rotate anti-clockwise. Now look at this arrangement over here. So you have 4 gears like this, and let's say that this gear is rotating clockwise. Then what does that mean for this second gear? So this second gear must therefore rotate anti-clockwise. But if the second gear is rotating anti-clockwise, that means that this third gear must rotate clockwise. And if this third gear is rotating clockwise, it must mean that this fourth gear is rotating anti-clockwise. So if you, I don't know if you have observed a pattern here, there is a pattern here. So whatever the direction of the first gear will also be the direction of the third gear, the fifth gear, and so on. And whatever is the direction of the second gear, which will be opposite to the first gear, will be the direction of the fourth gear, and so on. So the pattern here is, if the first gear is clockwise, so clockwise, anti-clockwise, clockwise, anti-clockwise, and so on. So that is the key idea that we'll now use to solve our original problem. So this is our arrangement, the original arrangement, and let's say that gear 1 is rotating clockwise. Now what does that mean for all the other gears? How will all the other gears rotate? So if gear 1 is rotating clockwise, it means all the odd numbered gears will be rotating clockwise and all the even numbered gears will be rotating anti-clockwise. So for example, we'll go clockwise, then anti, then clockwise, then anti-clockwise, clockwise, anti-clockwise, clockwise, anti-clockwise, clockwise, anti-clockwise, and clockwise. So what this really means is that the 11th gear should also be rotating clockwise. But now you see this doesn't work because the first gear and the 11th gear are also interlocking with each other. They are adjacent to each other, and two adjacent gears can't rotate in the same direction. And therefore, what will happen is if you try to rotate the first gear, the whole assembly will be stuck because the 11th gear will also try to rotate in the clockwise direction. So pretty cool, very cool idea here. I don't know if you like this, but I actually love this idea here. It's a very beautiful application of the idea of parity once again. How does parity figure in here? Because you see that the parity of the number decides the direction in which it rotates. So, here for example, all the gears with odd numbered parity are rotating clockwise, all the gears with even parity are rotating anti-clockwise. And therefore, just by looking at the diagram, we can immediately say, look, there are 11 gears in this, so and the first and the 11th gear should be rotating in the same direction, but they are also adjacent, so therefore, the assembly will get stuck. Okay, now here's a question for you. Here is an assembly of 20 gears, once again arranged in a circular manner. Let's say I try to rotate gear number 1 in a clockwise direction. Will this system of gears rotate or not? Yes or no? %90 of you are saying yes this time. So, we will give it a few more seconds and see, hopefully everybody responds by then. Okay, so in this case, the first gear and the last gear, they are of different parity. So, which means that gear number 20 here, the last gear, should be rotating anti-clockwise, and that should work then. So, if this is clockwise and this is anti-clockwise, that actually works for us, and therefore, this whole assembly will actually move. If you rotate this gear, the whole assembly will move, but the direction of movement of each gear will alternate. So, if this is clockwise, then all gears at odd numbers will be clockwise and all gears at even numbers will be anti-clockwise. So, you see how cool this is. If you do not know the underlying idea here of how parity figures in here, it will be very hard to figure this out, and if you actually try showing this to a friend and try asking this problem to a friend, and I am pretty sure most of your friends will actually find this very hard because they do not know the underlying idea here, but now you know it, and if you see a problem like this, you should be able to solve it instantly. So, I hope you liked this one. Okay. So, the answer here is yes. And now, we will come to problem number 5, our next problem, which is a different context in which parity comes in. So, imagine this book here, which has pages in it numbered like this. So, here is page number 32, this next one here is page number 33 and so on. Now, imagine that somewhere from this book, 3 sheets are torn away, 3 sheets are torn. So, if you take all the numbers on those 3 sheets, so you will have a total of 6 numbers. What will be the sum of the page numbers on those 3 sheets? Will that sum be even or will it be odd? Ragesh says either, Earthy says even, Lakshmi says odd. Wow, so answers to this one are quite mixed. So, here's how to think about this situation. So, if you take you tear any 3 sheets. So, let us imagine tearing this sheet over here, the one that we see over here at the top. So, this has 33 on the top side. So, what will be the number on the bottom side of this sheet, on the other side of this sheet? So, that number will be 34, and you take any other sheet from the book, the number on one side will be even, will be odd, and the number on the other side will be even. So, that is the key idea here. So, from every sheet that you tear, you will get 1 even number and 1 odd number, which means that in total you will get 3 even numbers and 3 odd numbers for a total of 6 numbers. So, you will get 3 even numbers and you will get 3 odd numbers, and now if you sum them up, what should you get? So, 3 even numbers will sum up to an even number, 3 odd numbers will sum up to an odd number, and then this even and this odd will sum up to an odd number. So, ultimately the total sum of the 6 numbers will be odd. So, you do not even need to think about which sheets will be torn, what specific numbers will come up, etc., etc. You just need to be able to think that the idea here or the pattern here or the secret here is that for every sheet torn, you will get one even number and one odd number, and therefore 3 even and 3 odd for a final sum with odd parity. Okay. So, now here are 3 problems for you, and I need you to answer them together in the chat. What would the sum be? Will it be odd or even if you tore 4 sheets, 7 sheets and 10 sheets? So, what are your answers in this case? And just tell me the answers together in a single message. For example, your answer could be odd, odd, even, or even, odd, even, or whatever. Deepika says odd, even, odd. Lakshmi says even, odd, even. Wow, that's completely opposite of each other. So, we'll give all of you a few more seconds. Shravan says all even. Gurpinder says even, odd, even. So does Gagan, Dipali, but Anuradha says odd, even, odd. Okay, so let's see. If 4 sheets are torn, you will get 4 even numbers and 4 odd numbers. So 4 even numbers and 4 odd numbers. So 4 even numbers will add up to an even number. 4 odd numbers also will add up to an even number, because you can pair up 2 odds and you get evens. So finally you should get a total sum that has even parity in this case. If you have 7 sheets instead, you will get 7 even numbers and you will get 7 odd numbers. The 7 even numbers will add up to an even number. The 7 odd numbers will add up to an odd number, because you can pair up 6 of the odds into 3 pairs, but you will still have an odd number. So ultimately you will get an odd number as the sum, and if you now finally find the sum, the even and odd will add up to an odd number. So if you have 7 sheets torn, you will get an odd number as the sum. What if you have 10 sheets torn? So you have, in this case, you have 10 even numbers and you have 10 odd numbers. So the 10 even numbers add up to an even number. The 10 odd numbers also add up to an even number, because you can pair up these 10 odd numbers into 5 pairs, each with an even sum. So finally you should get even plus even, which is even. So the correct sequence here is even, odd, even. That was the correct answer here. So to those of you who got this right, a great job figuring this one out. Okay, now here's a poll for you. Which of these could be the sum of page numbers if 5 sheets were torn? So you have 4 options: 25, 50, 75 and 100. Which of these could be the sum of the numbers if 5 sheets were torn from the book? So first think about whether the sum of the numbers on the 5 sheets will be even or odd, and accordingly pick your option. So 56% of you have picked the first option, which is 25. So let's see if that is indeed correct. So 5 sheets torn means you will get 5 even numbers and you will get 5 odd numbers. 5, let me just write odd here. So 5 even and 5 odd. The even numbers will sum to an even number. The 5 odd numbers will sum to an odd number, because one of the odd numbers can't be paired with another odd number. So you have even and odd, and now this will give you an odd number as the final sum. So you know for sure that the sum you will get is odd, and there are 2 options here. There is 25 and there is 75. So which one should you pick? Most of you have picked, 60% of you have picked 25, but why can't it be 75? So the other second secret here in solving this problem is, now you need to think about what could be the possible let's say, value or range of values for this sum. So, even if your sheets are the first 5 sheets of the book, you know, the lowest possible numbers in the book. So, what would those numbers be? So, you would have 1 and 2, 3 and 4, 5 and 6, 7 and 8, 9 and 10. So, even if you picked the lowest possible numbers of the book, even if you tore only the first 5 sheets of the book, you would get these numbers as the 10 numbers. And even this sum, the lowest possible sum you could get is actually much greater than 25. This sum is actually 55. If you add up these 10 numbers, it is 55. So, there is no way you can get 25. There is no possible set of 5 sheets you can tear to get the number 25, because even if you pick the lowest numbers, you will get a sum of 55. So, the only correct answer possible here is 75 and not 25. So, most of you got this one incorrect. In fact, it is easy to see which combination will get you 75 as the sum. So, if you start from 3, 4, 5, 6, 7, 8, 9, 10 and then also add 11 and 12, and now see what sum you get here. So, let us add these up quickly. So, 3 and 4 is 7, 5 and 6 is 11, 7 and 8 is 15, 9 and 10 is 19, and then 11 and 12 is 23. And now you add these 5 numbers. So, you get 18, 33, 52 and 75. So, the numbers starting from 3 and going up to 12, these 5 sheets will give you the sum 75. So, it is indeed possible to make 75, but it is not possible to make 25 at all, even though 25 is of odd parity. So, that was the trick here. You had to figure out both the final parity of the sum and you had to figure out which one of 25 or 75 was possible in this case. Okay. Now, we come to problem number 6, which is different theme, but again very interesting. So, you have these numbers. So, here you have 1, 2 and 3 and you have these boxes and you have to place plus and minus signs in these boxes to get to 0. So, can you do that? So, in this case, for example, you have 1, 2, 3. Can you place plus and minus signs here to get 0? And then here again you have 1, 2, 3 and 4 and you have these 3 boxes. Again you have to do the same thing to get 0. So, tell me if you can do that in the comments. So, 1 plus 2 minus 3, as some of you are saying already. Yes, 1 plus 2 minus 3 works. So, for the first one, 1 plus 2 minus 3 will work. What about the second one? Can we get to 0 with the second one? With the second one, can we get to 0 with the second one? Okay, so I am going to show you how to get to 0 with the second one. So, you put a minus sign here and you put a minus sign here and you put a plus sign here. So, you have 1 minus 2 minus 3 plus 4. Now, why does this work? Because your 1 and 4 are adding up, so that is 5, and from 5 you are subtracting 2 and 3. So, 5 minus 2 minus 3, that is 0. So, you can get to 0 in this second one as well by placing minus signs in the first 2 boxes and plus sign in the third one. So, that is the idea here. You figure out smartly what combination of plus and minus signs to do to get to 0. I will show you how to do that for every situation, but here is another problem for you. You have from 1 till 7 and you have 6 boxes. Can you place plus and minus signs here to get to 0? Let me see if any of you can figure this one out. The first correct answer here will get a call out. Okay, Saiba says 1 minus 2 minus 3 minus 4 minus 5 minus 6 plus 7. I don't think that works, Saiba, because I don't think it works. I'll give you a few more seconds. Okay, Anuradha says 1 minus 2 minus 3 minus 4 plus 5 plus 6 minus 7. I think that still doesn't work. No, I don't see any correct answer yet. Navyam says 1 minus 2 minus 3 minus 4 plus 5 plus 6 plus 7. No, even that one doesn't work. Kamaldeep says 1 plus 2 plus 3 minus 4 plus 5 minus 6 plus 7. Even that doesn't work. No, I don't see any correct answer yet. Ragesh says 1 minus 2 minus 3 minus 4 plus 5 minus 6 minus 7. Nope. Okay, I think I have one. Satvik says 1 minus 2 minus 3 minus 4 minus 5 plus 6 plus 7. Yes, that works. Okay, so I think the first correct answer was by Satvik, and let me use that answer. So I put minus signs here and then I put plus signs here at the end. So you get 1 plus 6 plus 7, so that's 14 in total, and then from 14 you subtract 2, so that's 12, you subtract 3, that's 9, you subtract 4, that's 5, and you subtract 5, that is 0. So that's one possible way you can get to 0 in this case, but maybe there are other ways as well. So if I place, for example, let's see, if I place a plus sign here, so I have a 1 here, and I can place perhaps, let me just erase these. Let me place a plus sign here and then a plus sign here and a plus sign here, and then negative signs in the other boxes. So let's see if we get to 0. So I have placed plus signs at 2, 5 and 6. So the numbers that are adding up now are 1 and 2 and 5 and 6. So that's a total of 14, and then you subtract 3, that's 11, you subtract 4, that's 7, and you subtract 7, that is 0. So that's another way to get to 0. So there are multiple ways to get to 0, but you have to be a little smart about how to do that. So here's one last one for you, and then I'll tell you the trick involved in how to do this. So you have the numbers from 1 to 5 and 4 boxes. Again, you have to place plus and minus signs. Can you get to 0 in this case? Quickly. Can you get to 0? First correct answer gets a call out. Rutul says 1 minus 2 minus 3 plus 4 plus 5, that's not 0. Satvik says not possible. Oh, that's interesting. Why is that not possible, Satvik? Please share your reasoning. Navyam says 1 plus 2 minus 3 minus 4 plus 5, that's not 0. Shweta Rao says the same thing. Shweta, that's 1, I think, not 0. I don't have any correct answer yet. You should verify your answers carefully, because none of the answers that's being shared so far is getting to 0. Satvik says odd addition cannot halve. Okay, we'll let's now understand the logic here. So this is actually impossible to do. No matter whatever you place, whatever combination you take of plus and addition and negative signs, you will never get to 0. And let me actually explain why that's the case. So to get to 0, what you need is the numbers that are being added and the numbers that are being subtracted are of the same magnitude. So for example, if you place, let's say, a plus sign here and a plus sign here and a negative sign here and a negative sign here, So what you're really doing is adding 1 and 3 and 4, which is giving, so all the positive numbers are adding up to 8, and then the numbers being subtracted are 2 and 5, and 2 and 5 in total is 7. So from 8 you are subtracting 7, and that gives you 1. But to get to 0, whatever you are adding and whatever you are subtracting should be the same. So that's the key idea here. The only way to get to 0 is if the numbers you're adding and the numbers you're subtracting are adding up to the same things. So, when you do the final combination, you get to 0. But the problem here is that these numbers 1, 2, 3, 4, 5 in total, that's a total of 15. So if you add up all of these numbers, that's a total of 15. So there is no way to separate the numbers in a way that the numbers being added and the numbers being subtracted add up to the same amount. Why? Because 15 is of odd parity. So 15 is of odd parity, and therefore there is no way to separate numbers in 15, the 5 numbers that add up to 15, in a way that their sums are equal. And that's really the key idea here, and I think Satvik and some others of you got this one. So, but why is it possible in this first example here? So the numbers from 1 to 7, because if you add up the numbers from 1 to 7, you get a total of 28, which is even parity. And now if all you need to do is figure out how do you find a combination in which the numbers being added add up to half of this, so that's 14, and the numbers being subtracted also combine to 14. So if you are able to do that, you will be able to get to 0. And that's what I was really doing in my mind when I was trying to find combinations that get me to 0. So I was trying to think, how do I place plus and minus signs such that the numbers being added get me to 14, the numbers being subtracted also add up to 14, and then I do the combination. So what I did, for example, was I took 1, 2, 5 and 6 as the numbers being added. So that gives me 14. As you can see, 1 plus 2 plus 5 plus 6 is 14, and then the numbers, the remaining numbers are the ones you need to subtract. So 3, 4 and 7. So these 3 numbers also combine to 14. So that's how you can figure out what combination will work. You just take half of the total sum as the numbers, the numbers you need, the positive numbers, the addition of the positive numbers, and you take half of that total number as what you need from the numbers being subtracted. So that's really the key idea over here. Okay, so based on that, here is now a poll for you. Which of these is impossible to do? So you have to place plus and minus signs to get to 0. Which of these is impossible to do? So I see some of you are talking about Taylor Swift. So maybe let's tone that down a little bit and talk about odd and even parity in this, because that's what the session is really on. Okay, the majority of you are picking option B. So we'll see in a minute which one is correct. All right, so what all we need to do is to look at the total sum of the numbers written. So 1 plus 2 plus 3 plus 4, that is 10, which is even. So separating this into 2 equal halves is possible. In fact, if you place a plus sign here and negative sign here, you get to 0. Then if you take 1, 2, 3, 4, 5, 6, this total is 21. So separating this into 2 halves is not possible. But if you take 1 to 7, that's 28, a total of 28. So this is doable, as we actually saw in a previous slide. And then if you take 1 to 8, the total sum here is 36, because you have the sum of 28 till 7, and then you add an 8, you get to 36. So 36 you can also separate into 2 equal halves, 18 and 18, and therefore getting this also to 0 should be possible. In fact, let's try that out. I need my numbers adding some numbers adding to 18 and some numbers, the numbers being subtracted also, subtracting out 18. So let's see how to do that. So I have this one here. I need 17 more to get to 18. So is it doable? So let's see. 17 more could be from, let's say if I add 4, 6 and 7. So and then I place negative signs here. So what do I, and here as well. So let's see, the numbers being added are 1, 4, 6 and 7. That's a total of 18, and then the numbers being subtracted are 2, 3, 5 and 8. That's also 18. So that is how you get to 0 in this case. But in option B, the problem is that the numbers are adding up to 21 and there is no way to separate 21 into 2 equal halves, and therefore this is not doable. So the correct option here is option B. Okay, now quickly last 2 puzzles and then we'll get to the Kahoot. So these are level 3 puzzles, so somewhat more difficult. Here is a chessboard, but 2 of the squares have been taken out. So this is a broken chessboard. So it's an 8x8 chessboard, but 2 of the opposite squares have been taken out. Can this be covered with 2x1 dominoes? Yes or no? So this is a poll for you. So you should see 2 options coming up, yes or no. So please share your answers in the poll. Can this be covered with Okay, so most of you are saying yes, it can be, and I think the reasoning you are following is that there are 64 squares in total on the chessboard. You take off 2 squares, so that is 62 squares, which is even, and this 2x1 domino has 2 squares, and therefore it seems like it should be possible to cover this with 2x1 dominoes. But actually, and very interestingly, the answer in this case is no. You cannot cover this broken chessboard with 2x1 dominoes, and that is why, by the way, this is a level 3 challenge. So the answer in this case is no, and let me tell you why that's the case. So please listen to me carefully, because the idea here is actually somewhat involved and you need to think about it hard. So what I need you to think about is, in this original chessboard, if you take the original 8x8 chessboard, how many squares are there in total? So there are a total of 64 squares. How many of those are black and how many of those are white? So on a typical chessboard, you have white and black squares. Here you can see black and red perhaps. So how many are black, how many are red? So you have 32 black squares, you have 32 red squares. So an equal number of black and white squares. But if you take out these 2 squares at the opposite edges of the chessboard, what is the new number of squares now? So which colored squares have you taken off? So there should have been a black square here, and there should also have been a black square over here. So what you have done really is you have taken out 2 squares of the same color. So you have taken out 2 black squares, which means that now on this broken chessboard you have 32 white squares or red squares, whatever this color is, but you have only 30 black squares left now. So that's the key insight here. So when you take out 2 squares from the opposite edges, you're taking out 2 squares of the same color, and therefore the number of squares, differently colored squares, now is not the same anymore. So you have 32 white squares and you have 30 black squares. But now if you think of this domino and what this does when you place it on the chessboard, what happens when you place a domino on a chessboard? So let's take this domino and let's say place it here. So which 2 squares does it cover, and what are the colors of those squares? So it covers this square and this square, and one of those squares is black and one is white. And this is true no matter where you place this domino. So if you place this domino over here, it covers one black and one white. If you place this domino here, it covers one black and one white. So every time you place a domino anywhere on the chessboard, you will cover one black and one white square, which means that if you place a certain number of dominoes on this chessboard, you should have covered an equal number of black and white squares. For example, if you place 31 dominoes on this chessboard, you should have covered 31 black and 31 white squares. But what you need to cover is 32 white and 30 black. So you need to cover a different number of white and black squares, and therefore doing this is not possible. So that's the key idea here. This is like, all of you are from grades 3 to 5, but this is actually a problem even high school students are unable to solve, because it involves this thinking, this deep thinking here, that the number of squares, the number of white and black squares become unequal when you take out squares in this way. You are left with 32 white and 30 black squares, but a domino always covers one white and one black square, and therefore covering this broken chessboard with these dominoes is impossible. So that is the answer over here. What about this one? So you have this 5 cross 4 chessboard with these squares taken away. Can you cover this one with 2 cross 1 dominoes? So quickly, what is your answer here? Yes or no? Okay, so some of you are saying yes, we can. So let's see. So in this case, you have the original chessboard has 20 squares. You take out 2 of them, and here there should have been a black square, here there should have been a white square. So here you now take out 1 black and 1 white, and you are left with 18 squares, of which 9 are black and 9 are white. So therefore it should be possible to cover this chessboard with these dominoes. In fact, if you try doing that, you will see. So you place one here, 2, 3, 4, 5, 6, and then 7, 8 and 9. So yes, it is indeed possible to cover this one with 2 cross 1 dominoes. Now here's a poll for you. Which of these broken boards can be covered with 2 cross 1 dominoes? So you have an 8 cross 6 board, 2 squares taken off, 7 cross 5, 2 squares taken off, 8 cross 7, 2 squares taken off. Which of these can be covered with 2 cross 1 dominoes? % of you have picked option C. So let's see. So you have 7 cross 5 in option B, which is 35 squares, take off 2, so that's 33 squares, which is odd. So this obviously can't be covered with 2 cross 1 dominoes. Here you have 8 cross 6, so that's 48 squares, and you take out 2 of them, so you're left with 46. But let's see what the colors are. So this is black and this is also black. So you take out 2 black squares, which means that in the 46 squares, you will have an unequal number of black and white squares. So even this one can't be covered with 2 cross 1 dominoes. But here you have 56 squares originally. You take out 2 and you take out a white from here and a black from here. So you're left with 54 now, of which 27 will be black and 27 will be white. So in this one you can cover this with 2 cross 1 dominoes. So the correct option here is option C, and great job to those of you who got this one right. Okay, so that concludes our learning part, and there was actually a couple of more additional challenging puzzles, but we'll stop here and we'll actually get to the Kahoot now. So be ready. Now it's time to do our fun Kahoot quiz. So it's time to apply and show what you have learned in this entire session and see how you do on the leaderboard. So give us a minute as we set this up. So the game pin is 5274675. So go to kahoot.it, kahoot.it, or if you have the Kahoot app, you can directly put the game pin over there, 5274675, and just join the game using this game pin. So if you don't have the Kahoot app, don't worry, just go to kahoot.it, kahoot.it, and join the game using this game pin. Okay, we are going to give it one more minute to have all of you join in. We'll start in 30 seconds. Students, get ready, and remember, you have to be both fast and accurate to do well on the quiz. Okay, 10 more seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, and here we go. All right. So here's our first question. Are you ready? So it's just to get you used to the format. So you just have to pick yes or no. Okay, all of you are ready, so great to see that. Let's look at this screen now. So you'll see this leaderboard that's come up. Right now it's all at 0 because this was a test question, it was a dummy question. But now going forward, as you answer correctly and depending on how fast you are, you should show up on this leaderboard, and your ranking will be based on both your accuracy as well as your speed. So be accurate, be fast. Think deeply, think carefully, and do your best. Okay, let's go. Here is our first question. You start on bank A, you cross the river twice a day. After 5 days, which bank are you on? All right, so the larger number of you said bank A, which is the correct answer, because after 5 days you would have made 10 crossings because you're crossing the river twice a day. So 10 is an even number, and even means you will be back on the side you started with. So if it's A, you go B, A, B, A, B, A, and so on. So all even numbered crossings should get you on side A. So that was the correct answer. So let's see the leaderboard now. All right, Kyan Chaudhary at the top, Sifat, Alicia, Ayush, and Anjay. So these are our top 5 players. Great job, keep that up. Let's keep going now to the next question. Initially, a bulb is off. It toggles on and off with each flip of a switch. After 9 flips, is it on or off? Okay, the correct answer was on because the bulb starts in the off state and then on every odd number of toggles it should be in the opposite state, it should be in the on state, and 9 flips is odd. So, at odd numbered flips it should be in the opposite state, which is on, because you start from off and then you go on, off and so on, and therefore it should be on. Okay. So, let us see the leaderboard now. Kian still at the top, Darsh, Anjay, Alicia and Satvik. So, that is the top 5. Great job. Let us keep going now, lots of chances for all of you. This question is for double points now. Start on bank A, you cross the river once on odd days, twice on even days. After 6 days, where are you? Think about this one carefully. Okay, the correct answer was bank B. Why is that? Well, because you cross the river once on odd days and twice on even days. So, on even days you will just be back on bank A. On odd days you will be on, you will go to the opposite side because you will have crossed the bank, the river once. So, in 6 days you will have 3 even days, 3 odd days, and therefore you will in total cross the river an odd number of times, and that should take you opposite to bank A, which is bank B. So, that was the correct answer. Let us look at the leaderboard now. It's shuffled, okay. Darsh is now at the top, Anjay, Satvik, Rohan, and new name on the leaderboard, Nirosha. Mishi just hit an answer streak of 4. Great job to all of you, and to those of you who are not on the leaderboard, many more chances still to come. Be fast, be accurate. Let us go to the next question. Can you make 17 by adding 3 numbers from both boxes, even box, odd box? Okay, the correct answer was use 2 even numbers and 1 odd number, because the sum of 2 even and 1 odd will be odd, and 17 is odd. So, that was the only possibility here. Let us look at the leaderboard now. Shuffled. So, Darsh, Anjay, Satvik, Alicia, Kian's back on the leaderboard, and Anjay has a streak with 5 correct answers in a row. All right. So, let us keep going. Now, here is our next question. Can you cover a 3x7 grid with 2x1 dominoes? Simple question. Hope everybody gets this one right. Okay, most of you got this one right. So, it is not possible because 3 cross 7 grid has 21 squares, which is odd, and 2 cross 1 domino has 2 squares, that is even. So, not possible. So, let us see the leaderboard. It is not changed at all right, but it says Harini is the highest climber, up 5 places. Great job. Let us keep going. Few more questions still to go. We have a few gears attached in a straight line. If the fifth gear is rotating anti-clockwise, how is the first one rotating? Okay, anti-clockwise was the correct answer because fifth gear is anti-clockwise, so third should be anti-clockwise and then first should be anti-clockwise as well. So, let us see the leaderboard. Okay, shuffle a little bit. Kian now on 4, Rohan is back on the leaderboard, but the top 3 players still the same. Okay, so let us keep going now. Question number 8. You have 20 gears in a loop. The 7th gear is rotating anti-clockwise. How is the 10th, 12th one rotating? So, the correct answer was clockwise because the 7th gear is rotating anti-clockwise or counterclockwise, so all odd numbered gears should therefore be rotating anti-clockwise, but the 12 is of the opposite parity, it is even. So, the 12th gear should be rotating clockwise. So, that was the correct answer. Let us look at the leaderboard now. Changed again. Darsh, Satvik, Anjay still the same on the top 3, but Nirosha is number 4 and Rohan now is number 5. Okay, let us keep going to question 9 of 12. You pick 10 consecutive numbers that come one after the other. Will their sum be even or odd? Consecutive means numbers that come one after the other, like 2, 3 are consecutive, 4, 5, 6 are consecutive. Wow, very few of you got this one right. So, let me explain this for a minute. So, you have 10 consecutive numbers. You start from any number. So, let us say you start from 20. So, the 10 consecutive numbers will be 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 and so on, right. So, if you have 10 consecutive numbers, you can be certain that 5 of them will be even and 5 of them will be odd, because numbers alternate in parity. You start with even, the next one is odd, then even, then odd and so on. So, if you take 10 consecutive numbers, 5 will be even, 5 will be odd, the 5 even numbers will add up to an even number, the 5 odd numbers will add up to an odd number, and the total sum therefore will be odd. So, that was the answer here. The sum, you can be certain, will always be odd. So, let us look at the leaderboard now. It might have shuffled. It has now. Anjay at the top, SD is second, Darsh, Satvik and Desai, new name on the leaderboard. So, great job to all of you. Let us keep going. Question 10 of 12, this one is for double points. You pick 5 consecutive numbers. Will their sum be even or odd? think carefully and be accurate in your response. Okay, this one too, not many of you got this one right. In this case, the answer was it will depend on where we start. So, let me tell you why. So, let us say you start from 10. So, the 5 consecutive numbers would be 10, 11, 12, 13, 14. So, because you are starting with an even number, 3 of the 5 numbers are even and 2 are odd, and the total sum you will get is even. But if you start with an odd number, let us say you start with 21. So, the 5 numbers you will get are 21, 22, 23, 24, 25. So, now you have 3 odd numbers and 2 even numbers, and the total sum will be odd. So, depending on which parity you start with, you will get a different parity for the final sum. So, the correct answer here was it can be odd or even depending on where we start. So, let us see the leaderboard now. Changed again. Anjay at the top still, SD, Satvik, Brihat, new name on the leaderboard, and Desai, and then Advika Singh is the highest climber, up 16 places. All right, great job. Let's keep going now. This is our second last question. Can you cover a 6x6 grid with 2x1 dominoes if 2 opposite corners are removed? So, remove these 2 corners, these 2 squares. Can you do this? Okay, the correct answer in this case was no, it's not possible, because once you take out the opposite corners, you're taking out 2 squares of the same color. So, the number of black and white squares will be different, and therefore, the grid will not be you will not be able to cover the grid with 2x1 dominoes. So, the correct answer was no. Let's see the leaderboard now. Wow, changed again. Anjay, Satvik, Nirosha once again on the leaderboard, SD, Brihat. Mihira is the highest climber, 6 places up. All right, great job. Now we go to our last question, and this one is for double points. In an open book, page 32 is on the left. The sheet with one of the page number as 40 is torn. What's the sum? So, you might see an incomplete statement. The question is, what's the sum of the 2 numbers on the torn sheet? What's the sum? So, you tear a sheet with one of the page numbers as 40. What's the sum of the torn sheet, of the 2 numbers on the torn sheet? Okay, many of you I think picked 81 because you thought if 40 is on one side, then the other number should be 41, and therefore the total should be 81. But remember, in an open book, page 32 was on the left side. So, the even number was on the top on the left side. So, if you are tearing a sheet with page number 40, so look at this picture here. So, you have 32 over here, which means the number on this same sheet on the other side is 31, the number previous to it. So, now imagine a sheet with 40 on one side, which would be on this side, on the left side of the book. So, if you had 40 on the top side, you would have 39 on the other side, not 41. So, the total sum would be 40 plus 39 or 79, and that was the correct answer. So, let us see if that has changed our final winners. So, here's our podium. At number 3 is SD, okay. Congrats SD. At number 2 is Anjay, all right. And our winner for today's Kahoot is Satvik Garg, okay. Great job, and congrats to all the winners, to also to all of you who participated and put in your full effort. And since we are already on time, I'll just conclude quickly. Thank you all for attending today's session. And to those of you who are not QMath students, if you would want to get math help, to excel in math, you can consider taking a trial with QMath. But thanks to all of you for being part of today's session. I hope you had fun. If you did, if you learned something new, please leave a comment in the chat box before you leave. And I hope to see you again very soon in an upcoming masterclass. So thank you and have a good day.